In this question says, what is the purpose of providing two separate protocols UDP and TCP in the transport layer of TCP IP architecture? The purpose of providing two separate protocols UDP and TCP in the transport layer of TCP IP architecture is to offer different options for transmitting data based on varying requirement. That means suppose we want to send a mail to a person, suppose we want to retrieve information from any website, suppose we want to broadcast a live match for viewers. So all these are some tasks. So which task we want to achieve, based on that we decide whether we need UDP or TCP protocol. Suppose basically UDP is used when we are not worried if some frames or some packets are lost. That means if we are watching a live stream and if some frames are lost, so we will not be worried about that. So in such cases we use UDP, like gaming. When we are gaming, in that also we use UDP. Let's see some few differences. For TCP, it is a connection oriented protocol. That means there will be a receiver and a sender, and between them there will be a connection. And in case of UDP, it is a connectionless protocol. TCP is reliable as it is guarantees the delivery of the data to the destination router. And in UDP, there might be a packet loss. The delivery of the data to the destination cannot be guaranteed. An acknowledgement segment is present. In this, if sender sends some information to receiver, receiver will acknowledge. And if receiver is sending some information to sender, then sender will acknowledge. But in UDP, there is no such acknowledgement. TCP is slower because we have to first set up the connection between sender and receiver, and then we transmit the data, and then we have to discontinue the connection. And but in UDP, there is no such thing, so it is faster compared to TCP. TCP doesn't support broadcasting, and UDP supports broadcasting. Part B says physical address operates in a local domain, whereas logical address has a global domain. Explain why. So, so here physical address in computer network means MAC address, and logical address means IP address. So what happens? Suppose there are two networks, network 1 and network 2. Every network have a default gateway. Suppose this network has a gateway gate G1 and this network has a gateway G2. Default gateway, by that I mean, suppose there is a device which wants to connect to a network. Suppose this device is connected to network 1. So once this device is connected, so every device have a unique MAC address which is embedded in the device. So every device have a MAC address which is also unique. And once this device is connected to the network, it will assign a local IP address. Local IP address. Why it is called local? Because this IP address is only known to or restricted to this network. This network will not know whether this address exists or not. So it is called local. Now, if we want to send data to from one node to another node within this network, we can use this MAC address and local IP address to send this data from one node to another in the same network. But suppose we want to send the data from one network to another network. Since this IP address is not known to other networks, what happens? This node will send the data first to the default gateway. And what default gateway will do? It will change the local IP address to global IP address. Global IP address means IP address which is known to everyone in the world. So everyone in the world will know this IP address. So if somebody wants to send the data, then it can be sent. And this process is called NAT, Network Address Translation. Now, once this IP address is changed to global IP, this gateway will send a packet to the next router. Suppose he sends the packet to this gateway in the network 2. Now, once this gateway will receive the IP address, receives the packet, he will send the packet to the respective nodes where we want to send. Suppose we want to send packet to this node, then this gateway will send packet to this. So we can say local IP. That's why global IP address has a global domain, or we can say logical IP address has a global domain. Whereas when we talk about local IP address and MAC address, it is restricted to locally, or we can say within a network. Now let's see the differences. So physical address and MAC address, it is assigned by the manufacturer to identify devices within the same local network segment. Same local network. There are only relevant for communication within that specific network and are not designed to be routable. Routable means from one network to another network, this MAC address is not used to send beyond the boundaries of the local network. MAC address have a limited address space. MAC address uses a 48-bit address space, resulting in approximately to the 48 possible unique address. While this may seems like a large number, it is still finite and not sufficient for global addressing across the entire network. Now, if we talk about local IP address, local logical address or IP addresses, these are globally unique and can be used to identify devices anywhere on the internet. They are not tied to specific hardware and can be dynamically assigned or configured based on the network configuration. By not tied to a specific hardware, that means suppose there is a device. For every device, we know that we have a MAC address embedded. Now, once this device is corrupted, then this MAC address will no longer be in use. Be no longer in use. That's what it is saying. It is not tied to specific hardware. Next point is this allows device to communicate globally across different network segments and geographical locations. Now, next part is define bandwidth of a media. When we talk about bandwidth, there are two types. One is analog bandwidth and digital bandwidth. Analog means this type of signals, and digital means zeros, ones, this type of signals. So, analog bandwidth is the definition. It is the difference between upper and lower frequencies in a continuous band of frequencies. It is typically measured in units of hertz. And for digital bandwidth, it is the maximum rate of data transfer across a given path. It is typically measured in bits per second.